Rapid Spanning Tree Protocol 802.1W. Easy way to remember that is to think of Rapid Spanning Tree Protocol. This particular technology is the official IEEE enhancement to spanning tree, and one of two enhancements, as we'll see in the next lesson. But the thing about Rapid Spanning Tree Protocol is that it takes advantage of port fast, uplink fast, backbone fast. These technologies are either built in or still available. In fact, let me make that clear right now. Uplink fast and backbone fast are built-in behaviors now. There's nothing you have to configure in order to get their benefit. Port fast is the same as it ever was. Suddenly I feel like I'm the talking heads. The port fast feature, you're going to configure it the same way you always did when you are configuring your Rapid Spanning Tree Protocol. But you know what? I'm getting ahead of myself here on this introduction slide. Let's go ahead and see, let's enumerate, if you will, the key differences between Rapid Spanning Tree Protocol and its sibling, Classic Spanning Tree. The RSTP port states are simplified rather dramatically. Let's take a look. Under 802.1d, Classic Spanning Tree, we had states of disabled, blocking, listening, learning, forwarding, and under 802.1w, they got real smart here. They said, look, the port's either forwarding or not, thus the discarding and forwarding states, or it's in transition, and we'll simplify the transition states to just one, the learning state. So a simplification of the port states is where we begin to see engineered improvements in the convergence time for the protocol. The port roles have also been enhanced, and one of the things that you need to know about the port roles that's really super interesting is they are now decoupled from the port states. Let me explain, because a lot of people miss this point. The Classic Spanning Tree used to function in a manner where the state that the port was in was directly attributable to its particular role. For instance, if you were a non-designated port, you were by definition in the blocking state. That changes with RSTP. These four roles that we see here don't have that one-to-one relationship with the states. And this, again, can be engineered to give the better convergence times. The root port, same as it always was. We had a root port before, we got a root port now. The designated port concept, same as in the Classic Spanning Tree Protocol. What they did unique here was they created an alternate port and a backup port. The alternate port is an alternate port for the root port, a quickly converging port to a new route if we lose our root port. Easy way to remember this is just think of it as an alternate path to get to the root bridge. And there you go. You'll remember that the alternate port is a backup for the root port. Then we have a port called the backup port, and this functions as a backup to the designated port. So for the designated ports quickly converging backup, we have a port called the backup port. Notice these new roles help the engineers build in the uplink fast and the backbone fast behaviors. But the biggest enhancement regarding improved convergence for Rapid Spanning Tree Protocol is by far the new proposal and agreement process. This proposal and agreement process replaces Classic Spanning Tree's reliance on simple and inflexible timer values of max age, forward delay. In fact, you probably even remember the defaults for those. A max age of 20 seconds and a forward delay of 15 seconds. And I hope I'm right. Yeah, I think I'm right. But anyways, the simple use of timers has been replaced by this sophisticated proposal and agreement process. The proposal and agreement process, by the way, relies upon full duplex point-to-point connections between all your switches. And, that's no big deal, because I don't think there's an engineer out there in the audience right now that would want to connect their switches, the key fabric of their infrastructure, using half duplex connectivity. Can you imagine, hooking all your switches together using a hub? I mean, it's very, very silly. So we use point-to-point full duplex connectivity between our switches anyways, and that's good because it is a requirement for this proposal and agreement process to quickly decide upon a converged loop-free topology. There are certainly other RSTP enhancements, like the fact that the bridge protocol data unit now carries more information and functions as a keep-alive mechanism. The link types are now given an identifying characteristic, an identifying property. For example, if you have a full duplex link, it's identified as point-to-point. If you were to have a half duplex link, it's identified immediately as an edge port. And Rapid Spanning Tree Protocol will treat those ports differently in its operation. We mentioned earlier that you're still going to have port fast just like you did before. And another very interesting thing is the fact that in 802.1d, it was the root device that was responsible for informing everyone of a topology change. But now the bridge protocol data unit from all switches can function as a topology change notification mechanism, and that improves convergence. No longer do we have a switch saying, ooh, I just noticed there's a link state change. I got to tell the root so that the root can tell everyone else. That is pretty darn inefficient, and it is redone in Rapid Spanning Tree Protocol. Well, you're probably not surprised, but we're going to go back to our equipment here, and we're going to take a look at some of this at the command line. Now, first, I want to go to, let's go to switch 1, and let's do the show spanning tree output again for a VLAN. And you notice something very interesting, and this confuses a lot of students. It says here IEEE, so we think we're running classic spanning tree based on that, or maybe because that's so vague, we don't know what we're running. And then we look down here in the role column, and we see alternate. Alternate. This is the language of Rapid Spanning Tree Protocol. And we even see that the type of port is being identified. What is going on? I thought we were running per VLAN Spanning Tree Plus by default. This output sure makes it look like we are running Rapid Spanning Tree Protocol. Well, what's happening here is that the device is certainly ready to run Rapid Spanning Tree Protocol, and it's going to be compatible with devices running Rapid Spanning Tree Protocol. It's even making choices already, like what are the alternate ports and things of that nature. But it's not truly running Rapid Spanning Tree Protocol, and really our only proof here is right there. That's our proof, this IEEE designation. So let's run Rapid Spanning Tree Protocol. We don't have to start at the root or anything like that in order to do this. We say spanning tree mode, and then remember that rapid PVST option. That's it. That's it. Now, notice there are some interface state changes going on here, very interesting. And if we run the show spanning tree, we are going to see something important here. It's saying, look, we're now running RSTP, but understand you're not really taking advantage of RSTP because you are peering out these ports with classic spanning tree devices. So we definitely have to do our due diligence here and go to each device, spanning tree, mode, rapid. This would have been a good one to paste on the clipboard. In fact, let me do that right now. Let's see. Yeah, good. I've got that on the clipboard because this is obviously something we just want to quickly go to each device and paste in. And so much for quickly. All right, and one more. So nothing to this conversion. And the great news is, as you make the conversion on just some of the switches in your infrastructure, you won't get chaos because classic spanning tree, let me say this the right way, rapid spanning tree is indeed going to be backwards compatible with classic spanning tree. But obviously, once you get everything converted over, you're going to get just good, clean output here, and you'll see that everyone is running the rapid spanning tree protocol, and you'll notice that the point types are converted back to just their pure point-to-point designations. And now, these port roles that you're going to see reported, now they actually have true meaning and true value. It's interesting also, I just thought of this, never really contemplated this before, but it's also pretty funny that we have these timers that are still being displayed, which now is really, really legacy stuff. We know that in my environment right now, the max age has little to no significance. Well, thank you so much for attending this particular advanced technology session. Next up, in the next lesson, we're not leaving spanning tree protocol. No way. Instead, we are moving to a discussion of a sister technology to this one. It's 802.1S. S as in Sam. And no, I don't have a corny joke for you on that one.